Hello, ladies and gentlemen, and I'd like to talk about the concept of what we're learning here with the quadratic equation. So let's take a quadratic that we know. Y equals x squared plus 7x plus 12. Let's set that y equal to 0. And what we have now is x squared plus 7x plus 12 equals 0. And if I wanted to find the zeros to this equation, or the x-intercept values, what I would do is I would factor it. And we would look for two numbers that multiply to give 12, add to give 7, 3 and 4. So it's x plus 3, x plus 4. And we find out that our zeros are negative 3 and negative 4, which means that this particular parabola is going to be going through negative 3, negative 4. We can also tell that it has a y-intercept of 12, which means that it's going to be opening up. So its vertex is going to have to be down here somewhere, and it goes something like that. Okay, so that's what we know just from previous information. Now, using the quadratic formula, we have x squared plus 7x plus 12 equals 0. Now it has to equal 0. If it doesn't equal 0, we're in trouble. And the other thing is, you better make sure that your a value is positive. If your a value is not positive, it's going to really be hard to work through the formula. So the formula for the quadratic formula is x equals minus b plus or minus b squared subtract 4ac all over top of 2a. So what we have here is we have an a value of 1, we have a b value of 7, and we have a c value of 12. Plugging in those numbers, what we're going to get is x equals 7, so it's negative 7 because it's minus b, plus or minus 49, subtract 4 times 1, which is 4, times 12, which is 48, square root over top of 2 times 1, which is 2. So this is going to work out to negative 7 plus or minus square root of 1 over 2. That's going to be minus 7 plus or minus 1 over 2. So we have two answers here, minus 7 plus 1 over 2, which is negative 6 over 2, which is negative 3. And we have negative 7 minus 1 over 2, which is negative 8 over 2, which is negative 4. So using the quadratic formula, we came up with the same zeros for the equation as we did with factoring. And that's what this does. Now the nice thing about this is not all trinomials factor, okay? But the quadratic formula will work to find the zeros of all quadratics. So factoring, even though that it's fast and easy, only works on a select few quadratics, whereas the quadratic formula will work on all of them. So now, if we just looked at part of the quadratic formula, if we looked at just the part under the square root, that's called the discriminant. And we've talked about how the discriminant tells us a little bit about the equation. So in this case, our discriminant is given by 49 minus 48, which means your discriminant is 1, which means it's greater than 0. So that means that your discriminant means that you're going to have two distinct real roots. And that translates into two x-intercepts. And as we can tell, that's exactly what we had with this question. So just putting that all in together so that we can see it. Let's take a look at another example. Now I'm going to make this example up just off the top of my head. Y equals negative 2x squared minus 3x plus 7. So I don't know anything about this equation. I made it up. I do know that it will not factor because I'd be looking for two numbers that multiply to give 14, negative 14. And I know that it needs to add to give negative 3. And that's not going to happen. So this does not factor. So if I want to use the quadratic formula here to find the zeros, first thing I'm going to do is I'm going to set it equal to 0. Now, we've got a problem here. And that problem here is this negative And you can do it with a negative. It's just really hard. It's not fun. So I suggest that you bring that over. And so we'll make this 2x squared. We'll bring this over. We'll make this plus 3x. We'll bring that over, and we'll make it negative 7. And everything we do will be fine for this, but the original had the negative 2, so we're going to remember that it does, in fact, open down. This is going to give us the same x-intercepts, but it seems, if I look at this, that it opens up. So we've got to be careful not to use this for the direction of opening. But this is definitely going to be easier for using the quadratic formula, which is negative b plus or minus b squared minus 4ac square root all over top of 2a. So for this one, we notice that my a is going to be 2, my b is going to be 3, and my c is going to be negative 7. So what do we get here? We get b is going to be negative 3 plus or minus 9. 4 times a is 8 times 7. And it's going to be positive 56. And it's going to be over top of 4. So this is going to be negative 3 plus or minus 64. Is that right? Wow, that's kind of neat. 64 square rooted is 8. So it's negative 3 plus or minus 8 over 4. So remembering that there's two answers here, minus 3 plus 8 over 4, which is going to be 5 over 4. And the other answer is going to be negative 3 minus 8 over 4, which is going to be negative 11 over 4. And in your answers, we're going to change everything to decimals. So 5 over 4 is going to be 1.25. And negative 11 over 4 is going to be negative 2.75. And we would graph those by estimating where they go. Now, if the solutions that you're given give you fractions, I'm asking you for decimals. Just take the fraction, use your calculator, and check to see if they're right. Let's do another example together. Let's do y equals 5x squared minus 3x plus 4. Again, if I tried to factor it, I'm looking for two numbers that multiply to give 20 and add to give negative 3. It does not factor. I cannot do this with factoring. So if I want to find the zeros, I'm going to set it equal to 0. And what we're going to do is we're going to use the quadratic formula. So it's going to be x equals minus b plus or minus b squared minus 4ac all square rooted over top of 2a. Make sure that line goes all the way across. Make sure that line goes all the way across. So my a value is 5, my b value is negative 3, and my c value is 4. So it's going to be x equals 3 plus or minus square root 9, because negative 3 times negative 3 is positive 9. It's squared. Minus 4, which is 4, times 5, which is 20, times 4, which is 80. So that's actually going to be negative 80 over top of 10. What's interesting here is I'm getting a negative underneath the square root. So what that means is I'm going to get 3 plus or minus negative 71 over 10. This can't happen. Your calculator is going to have a real hard time with it. It's going to say error. Okay, and what that means is, the reason why you can't do that is because when you do the square root of something, like the square root of 16, you're looking for a number that multiplies by itself. So there's two of them to give 16, and that's 4. Well, the problem is negative, let's try, we try to do negative 16, that's not going to work because a negative 4 times a negative 4 gives me a positive 16, which isn't what I want. And a positive 4 times a positive 4 gives me positive 16, which is not what I want. There's no way two numbers that are identical can multiply together to give me a negative. Because if the numbers are identical, then they're the same sign. And to get a negative, one has to be positive and the other has to be negative. So this is an error. There is no real number here. So what you say here is no real roots. There's no zeros. There's only a complex solution. You can say that if you want, but there's no x-intercepts. And sometimes it's nice to figure that out before you start a question. Sometimes it's nice to sit back and look at the question and say, is this even worth doing? And we do that by checking the discriminant. And the discriminant, as we know, is the part that's underneath the square root. So we look at that part and we simply plug in our values. And we're going to get 9 minus 4 times a, which is 20. So it's negative 80. And we notice that this is going to give you a negative number. So it's going to be less than 0. And we should know that a discriminant of less than 0 means no real roots. So in fact, had I done this first, I didn't have to do any of the rest. I could just say, you know what? There's no point doing this. There's not going to be any zeros. There's not going to be any roots. There's not going to be any x-intercepts. And we would be done. Okay, guys, that's enough. I got one more video doing some examples of the sheets, and then you're going to work on the sheets. We're going to have a quiz on this when you come back next day.